Hi everyone, myself Ayush Jaswal and I am making an explanation video of our data science end semester question paper of question 5th, where the question is we have to differentiate between supervised and unsupervised learning, parametric and non-parametric models, as well as write reference to text mining, describe accuracy, precision, recall, F1 score. This is basically used to determine the accuracy of the model, how much model, how much good a model performs after its evaluation. So we will go for our learnings. Now first we will go for parametric and non-parametric. Well, for exa for we and here is we focus on this algorithm assumptions, flexibility and complexity. The key differences between the parametric is fixed versus adaptive, interpretability, communicational efficiency, and linear regression, decision trees, logistic regression, and uh, k nearest neighbors. While their parametric models means models that fixed numbers of parameters independent of training data size, and the data flows specific function form, and finite and predetermined, and it doesn't change with more data. Example, linear regression and logistic regression. While parametric models advantages are it is computationally efficient, fast training time, lower memory usage, scalable to large data sets, interpretability and interference, clean mathematical form, parameters have meaning, easy statistical inference, and data efficiency. While non-parametric models with parameter count growing with training data size. This model grows with a training data size and where minimal or non assumptions about data distribution or functional form, variable to and here examples can be decision trees, k nearest neighbors, random forest, and svm is support vector machine neural networks. While non-parametric models have high flexibility, where non-functional form constraints capture complex relationships, handle non-linear patterns. It is robustness, fewer assumption about data, robust to outliners, flexible distribution handling, often achieve higher accuracy. Where parametric and differences between parametric and non-parametric are parameters. Parametric have fixed finite number, non-parametric as variable grows with data. While parametric assumption is strong, non-parametric is minimal or none, where the flexibility of parametric is low while non-parametric is high. Interpretability of parametric is high and have clear parameters, while in non-parametric there is low and black box. While in parametric training speed is fast, but in non-parametric the training speed is slower, and in data needed in parametric is less required, while in non-parametric is more required. Overfitting risk in parametric, underfitting risk higher, but in non-parametric overfitting risk higher. You can see underfitting risk is higher, and in non-parametric overfitting risk is higher. For example, parametric is linear regression, logistic regression, and in non-parametric it is trees, k nearest neighbors, and random forest. While we in real world we can use it for house price prediction, parametric like linear regression, and non-parametric for decision tree. Now the second part A, question B is supervised versus unsupervised learning, where the key differences are labeled versus unlabeled data. Supervised learning has a labeled data while unsupervised has unlabeled data, and the training data type and their learning goal and algorithms are different. While examples of this are classification regression is supervised, while unsupervised is clustering dimensionality reduction. It can be through PCA, principal component analysis. We have discussed in our video of that cheat sheet video and assignment playlist. You can see that PCA is explained fully. I have explained all the topics of PCA in our assignment playlist. And supervised learning, we are learning from labeled data where each sample has input and target output, and the purpose training process is model learns to map inputs output using labeled examples. Main types are classification and regression. Key requirements are labeled training data sets. While in supervised learning, applications and algorithms, classification tasks predict discrete categories, and regression tasks predict continuous numeric values. While in unsupervised learning, learning from unlabeled data, discovering hidden patterns without target labels. This is used in customer segmentation, what the customer is like, medium range person or low range person or a high class person. So this can be used in a shops too for customer segmentation, where there is the data is unlabeled. And the main types are clustering and dimensionality reduction. Now unsupervised learning, and supervised learning key differences are supervised have labeled data while unsupervised has unlabeled data. Supervised learning learns from input and output mapping, while in unsupervised learning it discovers hidden patterns. In supervised, the goal in supervised is to prediction using classification or regression, while in unsupervised it is to find insights and structure discovery. Evaluation in supervised is compared to known labels, while in unsupervised subjective or internal metrics. Data cost in supervised is expensive, while in unsupervised is cheaper. Complexity in supervised is straightforward objective, while in unsupervised it is ambiguous and success criteria. In real world it can be used for this I have said that customer market segmentation we use clustering. Now in supervised learning can be used for email spam detection, stock price forecasting using regression, choosing where we can see that choosing the right model integration guide, have a label data plus clean target, data is simple plus interpretability critical, complex relationship plus plenty of data, unlabeled data plus pattern discovery needed, need both accuracy and interpretability. Now ML models classification and paradigms, where parametric models use fixed parameters and strong assumptions for efficiency and interpretability. Non-parametric models are flexible but unbounded parameters capturing complex patterns at the most of computational complexity, while supervised learning trainings and label data for prediction, and while an unsupervised learning discovers patterns in unlabeled data. Choose based on data availability, interpretability, needs, and problem complexity. Thank you everyone. This is all for our video. Hope you like this video.